Course 3, Lesson 112, is all about looking at our right triangles and figuring out some ratios of the lengths of the sides. This is kind of an intro to trigonometry, which we will look at in a little bit more detail in another lesson very soon here. But just to begin with some of these different words that we will be using. So trigonometry explores relationships between sides and angles. It's used in a lot of different things like engineering, surveying, navigation. But just some words that we're going to use. One that we have already used many, many times is the hypotenuse. Now remember, the hypotenuse is the longest side of our right triangle always, and it's also opposite of that right angle. It's across from it. The other words that we're going to use, let's say we care about this angle A up here. Well, opposite angle A is this side over here, which we would maybe represent that side length with a lowercase a. Our opposite sides are always across from the angle that we care about. And then close to the angle that we care about is called the adjacent side. That adjacent side, adjacent means that you're next to it. So we actually are next to this side right here. So that would be considered our adjacent side. So we have opposite, we have adjacent, and we have hypotenuse. So we got to label the three sides of this one right here, caring about this angle B. Well, this one is always the hypotenuse. And because it's across from the 90-degree angle, the one that is opposite from the angle B is this one over here, so we would call that the opposite side. And then adjacent, okay, next to that angle B is this side right here, so we would call that adjacent. All right, so based on which angle that we care about, we can call these different sides different names. It's all based on where the angle is though. So we can use this to find the ratio of different sides based on the angles that we're talking about. In a future lesson, we will give these very specific names that are used in trigonometry. Right now, we're just practicing how to find those ratios. So find the ratio of the length of one side, the length of the side opposite to angle A compared to the hypotenuse. Okay, so we're going to do that for this first triangle up here. So here's my angle A, and I want the ratio of the side opposite, so we're talking about this one that's opposite, so 3 over, remember we can show ratios as a fraction, so to the length of the hypotenuse, which is right here my longest side of 5. So express this as a decimal, we would say this as a decimal is 0.6. How about this one over here? Let's say we care about angle Y, and I'm going to do the same relationship, opposite over hypotenuse. Well, opposite of Y is 8 over the hypotenuse of 10. We express it as a decimal as 0.8. Not really anything to it. It's really not supposed to be extremely difficult. We're just really gearing ourselves up for another lesson in lesson 112. Okay, how about this one? Find the ratio of the length of the side opposite angle X to the length of the hypotenuse. Now we care about angle X here. So we want the one that's opposite, so 6 over the hypotenuse 10, which is 0.6. Okay? All right, so what do we know about these triangles? One thing that's really important to remember about these triangles is that they're all right triangles. We have that right angle. So that's a big thing that we care about here. All of those ratios also have whole numbers as their side lengths. This is not always going to be true. So, for example, this one right here. This one is also a right angle, okay? Up here we know that these are right triangles because 3, 4, 5 is a Pythagorean triple, 6, 8, 10 is a Pythagorean triple, and 1 root 3, 2 is one of our special right triangles, where we have this pattern of 1 root 3 and 2 that we looked at earlier in a different lesson. So we want to find the ratio of the length of the side opposite angle R, to the length of the adjacent side. So opposite over adjacent, so 1 over the square root of 3. then we would use a calculator to find the ratio rounded to 3 decimal places. So you can think about that and plug it into your calculator, but you should get something that looks like this, 0.577. Now, what we actually do with this, and this comes up in a full other lesson later, this is called rationalizing the denominator. In mathematics, it's not correct to leave a square root in the denominator. So what we do is called rationalizing the denominator, basically saying, I want to get rid of that square root symbol. We can have a square root symbol in the numerator, so we allow the square root to be in the numerator by getting rid of that square root. The only way to get rid of that is by multiplying by 1, but that 1 can be represented in a lot of different ways. In this case, to get rid of that square root, I'm going to multiply by the square root of 3 over the square root of 3. What you'll notice is that we get the square root of 3 on top, that's totally fine, and we get the square root of 3 times 3, which is 9, on the denominator. But we can simplify that. Square root of 3 over 3. And that is actually how we would leave this answer. We would not leave it like this right here. And you will also notice that when you plug this into your calculator, it also comes out to 0.577. So we haven't actually changed the value of this ratio by rationalizing the denominator. Little hint here, all that the reason that I multiplied the square root of 3 is because I saw the square root of 3 in that denominator. That's all. So let's just do, I think, just a couple more pages here. So express each ratio as a decimal rounded to the thousandths and as a fraction. Okay, so 1 to 2, but I'm missing my hypotenuse. So let's figure out what the hypotenuse is. We plug it into the Pythagorean theorem, and we say 1 squared plus 2 squared equals c squared. So 1 plus 4 is 5 equals c squared. So this side length is the square root of 5 once I solve for that c. So we want the opposite side. We're always taking A as our angle that we care about. And I want the opposite side versus the adjacent. So 1 over 2 is 0.5, but I want it rounded to the thousandths place. So I'm actually going to show more of this, 0.500. Okay, and I have my fraction of 1/2. Okay, let's do it again. And opposite side to the hypotenuse. So opposite side, 1 over the hypotenuse of root 5. Now once again, I don't like that square root in the denominator, so I'm going to multiply by the square root of 5 over the square root of 5. So I get 1 times the square root of 5, so root 5 over the square root of 25, which is just 5. Ends up that this amount right here, and plug it into your calculator so that you can see it for yourself as well, is 0.447. Okay, so we have our fraction, we have our decimal. Okay, last one here, still caring about that angle A, adjacent side to the hypotenuse. So adjacent side, so next to it, and then the hypotenuse of root 5. So 2 over the square root of 5. Once again, I still don't like that square root in the denominator, so I rationalize it by multiplying by root 5 over root 5. I get 2 root 5. Remember, I can't put that 2 inside of the square root and multiply. Gotta say separate. And then I get 5 on the denominator. Okay, so here's my fraction and my decimal. Plug that into a calculator. You get 0.894. Okay. So in the future, in another lesson, we will talk about what names to give all of these different ratios that we are finding. And they are all based on our trigonometry in mathematics. So I'll leave this one for you to try out, but the only thing that is different is that we care about angle B in this one. Same hypotenuse, but we care about angle B. So see how that changes as far as my opposite side to my adjacent, and my opposite to hypotenuse and my adjacent to hypotenuse. All right, so that is all for this lesson, just a preview of what we're going to be doing in another lesson. I hope this video helps with your homework and for studying.